Hello, I'm Victor Nguyen, and my individual project for CYB332 is about DHCPs. So, what is DHCP? DHCP, which stands for Dynamic Host Configuration Protocol, is a network management protocol used to automate the process of handing out configuration information to devices on a network, such as it assigns IPs to different hosts. The DHCP server usually resides on its own machine, although lately as technology progressed, it is now integrated to be inside any modern modem, acting as an all-in-one. The configuration information includes IP addresses, DNS, TCP, and any communication protocol based over the TCP or UDP. So how does it help, or how can it help you? So DHCP reduces the need for manual configuration of IP addresses and other network settings. In turn, this makes it faster and easier to connect devices to a network. DHCP ensures that devices on a network have unique IP addresses, reducing the likelihood of conflicts and making it easier to manage the network resources. So it's very good for organization. DHCP allows networks administrators to centralize and automate the management of IP addresses and other network configuration settings, making it easier to configure and maintain large networks. So this is another point for organization. Uh, it also can provide additional network configuration settings beyond just IP addresses, such as DNS server information, subnet masks, and default gateway addresses, making it easy for devices to be accessed, and it's a lot easier to access the network resources as well. It also allows the dynamic allocation of IP addresses, meaning that devices can be added or removed from the network without requiring manual configuration of IP addresses, making it more flexible and scalable. So in summary, how can it help you? It's just very easy to use. It's faster, uh, very good for organization, and its scalability is really good as well. And everything is just set right there as well. The network resources just a couple clicks away. So options, what are some options people can use for DHCPs? Well, I'll name a few. So the first option is ISC DHCP servers. It's widely used, and it's a open source DHCP server that supports a range of features and can run on various operating systems such as Linux, Unix, and Windows. And then another one that is quite popular is the Microsoft DHCP server. It's a DHCP server included with the Windows server that supports a range of features and integrated with the other Microsoft networking services, highly compatible with Microsoft. I'll note. So pause right here. Uh, a widely popular DHCP built-in would be the router default gateway. So by default, home routers are set to use DHCP, whereas each connected device will receive the necessary settings from the router. So therefore, on a home network, the router serves as a simple DHCP that assigns this information to hosts. So the hosts can be laptops, smartphones, gaming consoles. This just basically simplifies the setup process for non-technological users and eliminates the need for manual IP address configuration. So everything's just built in right there. So when a device connects to the network and requests an IP address from a DHCP server, the server can provide additional network configuration information, including the IP address and the default gateway. The default gateway is typically the IP address of the router that connects the local network to the internet or any other internet network. So when a device needs to send traffic outside of a local network, it uses the default gateway to route the traffic to the appropriate destination. For example, if a device on a local network needs to access a website on the internet, it will send traffic to the default gateway, which will then route the traffic to the appropriate destination. By providing the IP address of the default gateway, the device with DHCP network administrators can ensure that all devices on the network are using the correct default gateway and that traffic is being routed efficiently. This can help improve network performance and reliability, uh, particularly in a larger networks with many devices. We'll use this image right here to create a scenario. So the Cisco router will act as the DHCP server for the 192.168.1.0/24 network, and IP addresses already assigned to it is the Cisco switch and the file server. These will be excluded from the DHCP pool to ensure they are not given out to other hosts and can cause an IP address conflict. So uh, if configured right, it should look something like this. And this is how you would set up the uh, default gateway DHCP for uh, any server. So DHCPs can also work alongside with DNS servers. So DHCP does not directly use DNS, but it can provide DNS server information to devices on a network so that they can use DNS to resolve domain names to IP addresses. So when a device connects to a network and requests an IP address from a DHCP server, the DHCP server can provide additional network configuration information, including the IP addresses of one or more DNS servers. The device can then use these DNS servers to resolve domain names to IP addresses. For example, if a device needs to connect to a website at the domain name, it will first send a DNS query to a DNS server to resolve the domain name to an IP address. If the device has been configured with the IP addresses of one or more DNS servers uh, with DHCP, it will use one of these DNS servers to perform a DNS query. The DNS server will then respond with the IP address of the website, which the device can use to establish a connection. By providing DNS server information, the devices with DHCP network administrators can ensure that all devices on the network are using the correct DNS server and DNS queries are being handled efficiently. This can help improve network performance and reliability. And this is especially great for larger networks with many devices, like enterprise networks. So in a large enterprise network, DHCP is used to, well, maintain the addresses. So this would be good for that. So this, we're given a scenario using InfoSec learning. We'll be using their virtual machines. They're like a lab simulator. So for this, we'll be simulating how to test and create DHCP scopes and connect it to other networks. So we'll start off by just click Start here, Administrative Tools, DHCP. And this is for like, what Windows is this? I'm assuming this is like Windows 8. Don't quote me on it. But yeah, so DHCP, plus we'll see IPv4 and version 6 as well. We'll be working with v4 though. These scopes are already preset by this lab environment, but we'll be creating our own scope. So to do that, we'll click Action, New Scope. Welcome Wizard next. We'll name this Internal Network. And description nice and easy, just internal network as well. So for this, the IP addresses are already provided in this lab environment, but in a real world environment, you would just use your own IP. You can figure that out using command or just contacting your internet provider. But what is provided is 192.168.12.150, 12.150, and that's just an IP address, like a private IP address that is commonly used in examples. 12 and 199. We'll keep this the same. So the IP range for this, we will do 192.168.12.151. And NIP and IP will do 192.168.12 and 155. Add that, make sure it's added. Nice, which it is. Click next. And for this, we will which time computer is connected. We'll just do this. Don't really need to mess with that. Since we're working on it right now, yes, we want that like that. And for router default gateway, let me pull it up for this VM. It is 192.168.12.1. Add that, make sure it is added. Yes, it is. Domain name and DNS server. It's already added for us, but you can also, if it's not there, you can manually do it yourself with a few extra steps, but since it's right here, it makes life easier. And this DNS IP address is what it's supposed to be, so everything seems correct. Next, Win servers, we don't need to add anything for that. So we'll just click next, and we do want to activate the scope right now, so because everything's configured, make sure it's finished. And you can see right here, scope 192 is currently active. And if you wanted to like configure it yourself if something is wrong, you can go to scope, just click scope 192.168.12.0, and you'll go to scope options. And then you just do like action and configure options, but in this case, everything seems correct as it's connected to everything. And yeah, this is just a scenario for older Windows computer provided by InfoSec Learning. So for this scenario, we'll be setting up a DHCP using Windows 11. So this will just, the DHCP will just assign IP addresses to this computer. And this is my personal computer using my at-home network as well. So the DHCPs, like I said in the intro, is already built into modems. So when my laptop connects to my network, it's automatically already set up the DHCP. But if it's not, you would want to go to search and type control panel. From there, you want to do network and internet, network and sharing center. You just right here will say your at-home connection, but I'm currently wired using Ethernet, so I'll just click that. From here, you want to click properties, and then from here, you want to click Internet Protocol version 4, TCP/IPv4. Click properties. In the option obtain an IP address automatically and obtain DNS server address automatically, this means that it's already connected to the DHCP. But if you wanted to turn it off, you just click this option, use the following IP addresses, and that in turn will automatically click this too, use the following DNS server address, and you just manually input whatever IP address and DNS server address you want. But I want to keep mine on, so I'll turn both of them back on. And yeah, that's how you would check or set up your DHCP at home. So we're going to take a look at two versions of DHCP. We'll see how they are used and the step-by-step process of connectivity. So for version 4 or IPv4, first step is DHCP v4 discovery. And for this, the message is sent by a device to request an IP address from a DHCP server on a network. The next step is DHCP v4 offer. This message is sent by a DHCP server in response to a DHCP discover message and includes the IP address, subnet mask, and other network configuration settings that the server is offering to the device. Next step is request. This message is sent by the device to request if the offered IP address from the DHCP server. And the final step is acknowledge. And this message is sent by the DHCP server to confirm that the device has been assigned the requested IP address and other network configuration settings. And this usually uses UDP ports, client 68 and server 67. So for IPv6, so version 6, it's slightly different in terms of the step-by-step process, but it's still a four-step process. And the first one is DHCP v6 solicit. And this message is sent by a device to request network configuration information from DHCP v6 servers. Next up is advertise. This message is sent by DHCP v6 server in response to a solicit message and includes the network configuration information that the server is offering to the device. Next is request. This message is sent by the device to request the offered network configuration information from DHCP v6 server. And final step is reply. This message is sent by the DHCP v6 server to confirm that the device has been assigned the requested network configuration information. So now we're going to talk about ways people can use DHCP with malice. This comes in the form of DHCP spoofing. What is DHCP spoofing? Well, DHCP spoofing is a type of cyber attack where an attacker impersonates a legitimate DHCP server on a network. By doing so, the attacker can assign fake IP addresses to devices on the network, which can lead to various security risks, such as interception of network traffic, theft of sensitive data, and even complete takeover of networked devices. DHCP spoofing attacks are typically carried out by interception and altercation DHCP messages between a client and a server, allowing the attacker to gain control over the network traffic flowing between them. So how does it work? Well, DHCP spoofing allows threat actors to redirect traffic to systems owned by the threat actor. In order to achieve this, the man-in-the-middle attack is used. What is man-in-the-middle attack? Well, man-in-the-middle, or MITM attack, is a cyber attack in which a threat actor puts themselves in the middle of two parties, typically a user and an application, to intercept their communication and data exchange and use them for malicious purposes like making unauthorized purchase or hacking or others. Phishing is a good example of man in the middle. Create an email that's falsified in hopes that an employer or employee clicks on it, thinking that it's from another company. But anyways, the way this method achieves its goal is to sit in between the legitimate DHCP server and the DHCP client. The threat actor intercepts traffic headed towards the DHCP server and vice versa. They may give out false IP addresses and illegitimate DNS servers to redirect the client to download malicious software, which leads to other attacks. So an example of a DHCP cyber attack is La Trobe University in Melbourne. So yeah, this was in Australia where they suffered a major network hack that led into a cybersecurity investigation. The university discovered that a malicious actor had executed a DHCP spoofing attack, which allowed the attacker to intercept and monitor traffic network. The attacker set up a rogue DHCP server on the university's network and provided false network configuration settings to devices that connected to the device. The rogue DHCP server provided a false default gateway IP address and DNS server IP address, which sent all network traffics through the attacker's computer. The attacker was able to intercept and monitor the network traffic of university employees and students, including sensitive information like usernames, passwords, and other confidential data. So the university immediately took action to secure its network and launched a full-scale cyber security investigation to identify the attacker to prevent future attacks. And this incident highlights the dangers of DHCP spoofing and the need for robust network security measures to prevent them. It is unclear at this time who was behind the attack of La Trobe University, but the university has stated that it is taking the incident very seriously and is committed to ensure the security of its network and data. Yeah, so this happened, and the university did use countermeasures. It's not provided, as they probably want to keep that confidential, but this incident like serves as a reminder that network administrators must be vigilant against attacks and exploit weaknesses, attacks that exploit weaknesses on their network infrastructure, and they should probably just take steps to recover and prevent attacks like this in the future. And that will take us to our next slide, prevention and security measures. So one of the detection methods is application log content. This is a method that monitors window logs and changes DHCP settings. This method also, what the fuck? So preventions and security measures. One way is DHCP snooping to prevent DHCP spoofing. Anyways, this security measure feature is available on many network switches and routers and helps it to prevent DHCP spoofing attacks. DHCP snooping intercepts DHCP traffic and validates it against the configured DHCP database, dropping any traffic that does not match. It's usually already set up, but if it's not, DHCP snooping should be enabled on VLANs, after which the trust setting of port connected to the DHCP server must be changed to trusted. DHCP packets for VLAN with DHCP snooping enabled are inspected. The second one we'll talk about is static DHCP binding. This security measure assigns a fixed IP address to a device's MAC address. This makes it difficult for an attacker to spoof the MAC address and obtain a legitimate IP address, thereby reducing the risk. Third security measure is port security. This is important because this security measure limits the number of MAC addresses that can be learned on a particular port. This can help to prevent an attacker from connecting a rogue device to a network port and launching a DHCP spoofing attack. And the last one we'll cover is DHCP auditing. Auditing DHCP logs can help detect DHCP spoofing attempts. Network administrators should regularly review DHCP logs for any unusual or unauthorized DHCP activity. There are more security measures that should be implemented, but we're only going to cover 4 right now. And yeah, that's the end of my presentation about DHCP. Thank you.